Windows 10? You do, don't you, Paul?
Yeah.
It looks like they've made a huge change in the last couple days. Or is that my imagination?
What makes you think that?
Just the whole way the appearance is. The start bar at the bottom is different. I now have a desktop that I never used to have.
I don't know.
You don't notice a big difference on your end, huh?
No, that's just...
Well, I always thought it was kind of strange that I never had a desktop before. In other
you never had
words,
a desktop?
this desktop over here on the left,
Mm-hmm.
I didn't used to have that. I could not
Really?
access that. No, I could only access this menu, and I could access whatever applications were running, like this. But that was it.
For the email sent.
Okay. I see it. To attachments, which one first?
The one on the left.
Okay, let's download both here. Might have to help interpret here. Hold on. Just a second. I got to figure out how to do this now. Let's see. I want to snap that left. There we go. Yeah, I was... You good with one, or do you want me to check everything you've done on one?
That first one was a example, the dividing line.
Okay.
There where it says homework and down, that's where my homework starts.
Okay, I gotcha. So let's look at number one under homework.
Mm-hmm.
Let me read it.
Alright, so during 1 week of playing basketball, Carmelo Anthony hits 30 shots from the floor and scored 68 points. Each shot was a 2-point or a 3-point shot.
On a word problem, what is always the first step? Always.
I don't know, it's been a long time since I've done word problems.
If you can remember this, it will make them so much easier for you. Okay? First step is to read the last sentence and figure out your variables. Well, let's let x equal, they're asking for how many of 2-pointers or 3-pointers he made. So x is going to be the number of 2-pointers. Y is going to be the number of 3-pointers. And it really is that simple to always start with the last sentence. And whatever they're asking for, make that your variables. Okay?
Alright.
Now let's go back to the beginning. He hit 30 shots from the floor and scored 68 points. What two equations can we write from that? What's going to equal 68 points?
2x plus 3y.
What other equation can we get from that sentence?
X plus y equals 30.
Now you have two equations and two unknowns. Let's solve it. How do we solve that?
So you multiply the x plus y equals 30 by negative 2.
Giving us,
So you
I always find it helpful to number these things, especially when you start getting 3 equations and 3 unknowns. Really helps numbering them, even when you only have 2 and 2. Because equation 1 isn't going to change, but we're going to change equation 2 to what?
So you're changing equation 2 to negative 2x minus 2y equals negative 60.
And I usually draw a line through that so that I don't get confused. Now what am I going to do?
You're going to add them.
What do you get?
You get 8 equals y.
How do you solve for x?
Solve for x by plugging in back into one of the equations. The easiest one to do is x plus y equals 30.
Yeah, usually the one that I crossed out is almost always the easiest one to use to solve for the other variable.
So x would equal 22.
Yeah. Okay. And I guarantee you word problems will all be that easy if you merely do that first step, which is to go to the end of the problem and figure out what your variables are. So let's look at the second one. So our first
step. Equation, modeling the situation and solve.
Now this isn't quite as easy because the last sentence says write a system of equations modeling the situation, as opposed to the previous problem where they said how many of each type shot did he make. In other words, the previous problem was very, very specific as to what they wanted. Well, what do you suppose the variables should be? Probably going to have 2 variables and 2 equations.
All right. I'd say that you'd have x plus y equals 17.
Let's define our variables always.
Yep.
If you jump straight in to the equations, it can be difficult. But if you always start by defining your variables, what they mean precisely, everything else is going to come automatically. Easy. So what are my variables going to be?
The variables are going to be the azalea plants and the...
What about the azalea plants?
How many of them?
In other words, this is an important part. The number of azaleas to purchase. Now, after you get used to this, you don't always have to spell it out, but I've found that it is very, very useful because this could be the price of azalea plants, right? And we don't want it to be the price. We can tell by the model here that we're going to purchase some number of azalea plants and we're going to purchase some number of rhododendrons. So we're going to let X be the number of azaleas to purchase and Y be the number of rhododendrons to purchase. Now, what equation can I write next?
You can write x plus y equals 17.
And what next?
20x plus 25y equals 400.
All right, now let's talk about one thing before we go on. A lot of times you don't need to use 2 variables to solve these problems. You can solve them in 1 variable. And the way I would do that would be X would be the number of azaleas that I'm going to buy, and 17 minus X would be the number of rhododendrons. In other words, I take this equation that you saw and I manipulate it so that I don't have to use two variables. I only use one variable. And then it becomes a one variable problem. I suspect that given that you're in Algebra 2, they probably want you to use two variables here. Yes? No?
Multiply the top of the number.
No, what I'm saying is that if you were in Algebra 1, I would say that they would probably want you to do this as a one variable problem. But the fact that you're in Algebra 2, I'm thinking, and especially since you've just done a system of equations involving three variables and three equations, that they probably want you to do this as a two variable problem, right?
Yeah.
Okay, what's the next step?
Multiply the top equation by -20. So equation number 1.
And then what next, Cole?
Add the two equations.
Okay.
The x's cancel. So add y equals 60. Add 5, y equals 4.
What's x equal to?
This equation. So x plus 12 equals 17. Subtract the 12, you get 5.
All right. Good. Seem pretty good at these. Only thing I can possibly imagine would give you trouble is the first part. In other words, as long as you always remember to do that part there, then you don't have any problem writing your equation. Are you hearing that noise in the background that I'm hearing? Like, sounds like waves are breaking?
Yeah.
What kind of speaker do you use? Is it a headphone?
I use my Surface, but I'm hearing it on like both computers that I use.
Yeah, no, I get that problem periodically from various students. I was just trying to pin it down as to what's causing it.
This is a Microsoft Surface I'm using right now, but
it could be on my end. It might be on my end. I don't know that it's on your end.
Yeah, I know. I'm just, those are the computers I use for this primarily.
But you have a built-in mic on that?
Yeah, it's built-in.
Okay. My mic is standalone. I know they usually recommend everybody gets a headphone set, so that you have the microphone right in front of your mouth, and I think it cuts back on feedback also.
Yeah.
All right. Let's do another one here. Not so hard. I mean, our problems here aren't going to be to solve the problem as much as setting it up. Go down and look at number 3.
Because I have a pair of headphones and a blue standalone microphone I could use.
Okay. You have those right now?
Yep, I do.
Did you plug them in?
Do it right now.
Because I haven't heard that sound in a while.
I haven't been using the microphone and stuff, but let me get it. It's right here. Oh.
Huh?
All right. So.
Well, that that made a huge difference. It stopped that
Yeah,
in midstream.
yeah, I think it. No.
And this is using a headphone and speakers or a microphone that's right in front of your mouth. Huh? I think I lost you. Still there, Cole?
Hello?
Yeah, now I can hear you again.
Sorry, the settings weren't set to the microphone on GoToMeeting.
But that definitely made a huge improvement. Yeah. I'm going to have to remember that. In fact, I may have to get one myself for my end. But let's do this problem number 3, because this is a little different.
All right.
What's the first step? In other words, normally you'll notice that on problem number 1 is all I had to do was go to the last sentence. Right?
Mm-hmm.
Find my variables. And on problem number 2, it wasn't that hard to figure out what the variables should be. Well, now problem number 3, I cannot just immediately go to the last sentence to figure out my variables. I have to read the whole problem. So tell me what my variables should be on number 3.
X is the number of tapes, and Y is the number of CDs.
Yeah.
And the equations are pretty much there in the quotes for you.
So 3x
plus 2y equals 39, and 2x plus 3y equals 36. 46, sorry.
Okay, how do you solve that?
Alright, so you're going to multiply the top equation by, this is going to come out as no solution.
Well, before you jump to that conclusion.
Yeah. Okay, so multiply the top equation by, oh, never mind, okay.
I understand why you said that, and that's not I understand exactly why you said it. But be careful about jumping to that solution. If it said 3x plus 2y equals 39 and 3x plus 2y equals 46, that's no solution.
Okay, yeah. I just recognized that, alright.
Okay.
So
give me a
multiply
equation 1.
So equation 1, you can multiply it by -2.
Okay.
You can multiply equation 2 just by 3. So 6x equals -4y equals 78, -78, yeah.
And then number 2, we're going to multiply by +3.
So you'd have 6x plus 9y equals 46 by 3. So you'd have 138. Yeah, okay.
Notice how I did that in my head. I multiplied 30 times 4, or rather 3 times 40, which is 120. And then 3 times 6 is 18, which I added to 120. That's the way to do arithmetic in your head. Not that you ever need to do it in your head. You'd always want to use a calculator on that. But when I do it in my head, I kind of do it in backwards of the way they teach you to do it on paper. Because the most important digit is that one, not the 6. In other words, if I'm off on the 6 by a little bit, it doesn't bother me so much. But if I'm off by a factor of 10, it's going to bother me a lot. So now what?
You there?
Yeah. Can you hear me?
Yeah, you just cut out there for a second.
Oh, Okay, so what's the next step?
The next step is to add it and cancel the x's. So you have 5y equals 60, yeah. So y equals 12.
And then probably that one's the easiest one.
Mm-hmm.
Once again, it's always one of the original ones, never one of the secondary ones. Because the secondary ones have always been multiplied by something, so they're always bigger numbers.
Mm-hmm.
Okay. Now, 3 variable ones. You're perfectly comfortable with those?
Not perfectly. It's kind of hit or miss.
We got 5 minutes here. I think I can do this quickly enough. Bring one up. Try here. Here's one. Let's do number 1. Hold on.
No, you're good.
Let me write it out. The most important thing is the pattern that you use to do these. First of all, they're almost all in standard format. In other words, all 3 variables are on the left, the numbers are all on the right. What's the first thing you want to do?
You want to isolate one of the variables that's 1 or -1 as its coefficient.
First thing you want to do is eliminate one variable by using 2 of the 3 equations. Okay? Which
Right.
2 are the easiest to eliminate a variable?
Easiest is 2 and 3.
Okay, add them together. What do you get? I'm going to call that equation 4.
So you get 5x minus y equals
Plus y.
2. Oh, plus y, sorry. Equals 2.
Okay. Now, this is what's important. I need an equation 5, and I want to eliminate the same variable I just eliminated. In other words, I need to eliminate z. And I can no longer use 2 and 3 to do it. I could do it using 1 and 2 or 1 and 3.
1 and 3.
Give me a new 3.
So the new 3 would be 6x minus 12y.
Hold on. We're multiplying it by 2.
Yeah.
We're multiplying 3 by 2, not 1.
Yeah.
So it's 6x plus 8y
8y.
minus 2z
It's 2. Yeah.
equals minus 4. Now we're adding 1 and 3. What do you get?
7x plus 2y
Hold it.
equals 1.
Excuse me. Go ahead.
Equals 1.
Now, look what you have. You have a system of 2 equations and 2 variables. Well, we know how to solve these. I don't have any questions that you know how to solve that. That's going to allow you to solve for x. Okay? Once you solve for x, go back, plug it into one of those 2 equations that I have circled, solve for y. Once you have x and y, now go back to one of your original 3 equations and solve for z. That's always the way you do it. In other words, you pick a variable to eliminate and eliminate that in your first 2 steps. In other words, you don't eliminate z and then next decide to eliminate x. That would give you 2 equations and 3 variables. which wouldn't do us any good. So whatever variable you eliminate with your first step, you got to eliminate that same variable with your second step. The only restriction is you have to use 2 of the other 3 equations. And when you're done, you're going to have an equation 4 and 5, and that's the goal, is to get it to 2 equations, 2 unknowns, then you can solve it. In other words, then this becomes an elementary problem. Started out as an Algebra 3 problem and ended up as an Algebra 2 problem. Okay?
Right.
And that's what the way you always want to solve 3 variables. You'll notice that every single problem on this page is not only in standard format, but every single one says solve it using the elimination method. That's because you always want to use the elimination method when you have 3 equations and 3 variables. It's rare that you'd want to use the substitution. If my third equation was z equals something, then I might want to use substitution. But that's the only time. When they give it to you in standard format, always think elimination.
Okay.
All right, Cole. You have a good week. I will talk to you next week.
Talk to you next week.